Good morning, sixth graders. It's a beautiful morning here in my little neck of the woods, and it feels just like a camp morning, cool, and I hear the birds chirping, and I regret that we can't be at camp. So one of the things that you do at camp is you do an instructional group called Hands-on Science. In Hands-on Science, we do a whole bunch of different experiments. So I'm going to teach you about two of them today, and these are things that I think you should have at home. I was able to improvise because some of my materials are at school, but hopefully you can try some of these at home if you're interested. So the first thing we're going to talk about is Newton's first law of motion. It says that objects tend to keep doing what they are doing. So that's kind of the abbreviated version, but what Newton's first law of motion says is that an object at rest stays at rest, or an object in motion stays in motion with the same speed and the same direction unless it's acted upon by an outside force, like friction. Friction slows things down, okay? It's an object's resistance to changing its state of motion. So for example, I know I have never done this, and I'm sure your parents and your bus drivers have done the same thing, but have you ever been in a car and all of a sudden someone slams on the brakes? When you do, what happens to your body? You go flying forward, right? Or mom and dad are looking somewhere. Not that mom and dad would do this, and I never have. Mom and dad are trying to figure out directions to go somewhere, and all of a sudden they see their road. And at the last second, they take the car and they turn it really quickly to the right to hit the road that you need to go to. Your body goes flying the opposite direction. Why does that happen? Because my body wants to keep going at the same speed, and when you slam on the brakes, my body wants to keep going, which is why I go forward. If my parents turn, or the car turns that I'm in, and my body goes the opposite direction, it's because as they turn this way, my body wants to keep going forward, so it pulls my body in the opposite direction. The next time you're in your car, try that out. Close your eyes so you don't know which way you're going, and you'll notice that your body goes forward, and it might move backwards if they accelerate the car, or if they turn, your body's going to go in the opposite direction because it's the Newton's first law of motion. So to practice this at home, we don't really have anything you can do with motion easily, but we do have a couple activities we did at camp that you could have used. So one would be if you have a bunch of blocks and you have note cards. These objects are at rest, so they want to stay at rest. This is the same thing. Have you ever seen someone pull a tablecloth out with with plates and things on the table? Now, I'll probably mess this up because my blocks aren't very heavy and they're already starting to blow away. But what you should be able to do is you should be able to pull these cards out. If you do it quick enough, the blocks will stay. Let's see how I do. Oh, and I made them fall. So I got two. Little heavier blocks tend to work better, but they're at school, so what am I going to do? Other thing you can do is you can take a stack of coins, like a whole bunch of quarters. You can sit them on my picnic table that obviously needs a new coat of stain, and you can take one coin and flick it and try to knock out that bottom coin. The rest should stay in the stack. I'm not very good at it. I usually send the coins flying, but every once in a while at camp we do get students who are pretty good at that. The last thing you can do, and this is really fun, you might want to use a plastic glass, but you fill it with water. You're going to put a piece of cardboard on top. Hopefully you have toilet paper at home with all the craziness going on. And then the last thing you want to do is put an egg on top. Now, Newton's first law of motion says an object at rest wants to stay at rest. So if I hit this piece of cardboard, I'm going to knock this light piece of cardboard and the toilet paper roll out. The egg should fall straight into the cup because it stays at rest. It has nowhere to go. There's no force acting upon it. But if I knock the rest of this out, you actually want to set it this way so it's not stuck in there. If I knock that out, it should fall straight into the glass because nothing's holding it up, so gravity pushes it down. Try that. All right, the other thing we do, one of our other stations, is we talk about density. Now, at school, we actually talked a little bit about density. We always use 50 milliliters of water, and we learned that 50 milliliters of water has a mass of 50 grams. So that means that water has a density of 1 gram per milliliter. So 50 milliliters was 50 grams, so 1 milliliter would be 1 gram. We're going to talk about density. Density is mass per volume of an object, or the degree of compactness. So basically, that's the official definition, but it basically means how much stuff or how much matter is in a certain volume or in a certain space. So take a bowling ball and a playground ball, or maybe this plastic softball versus a real softball. If I were to throw them up in the air, you can obviously see that there's, and I can't catch, there is a difference in weight of them because the one will blow away and not go straight back down. Okay, so a bowling ball and a playground ball of the same size would be the same thing. One is very dense, one that rolled away is obviously not. Okay, so density is what makes an object sink or float. So water has a mass of 1 gram per milliliter. So what you can do is you can take some different objects at home, like a coin, or an egg, or maybe some fruit. What do you think would happen? Fruit is made of a lot of water, right? So what would happen if I put a lime, or a lemon, or an orange into the water? Do you think it would sink? Do you think it would float? What about this coin? What about the egg? Does wood sink or does wood float? What are the densities of all of these objects compared to this water? Now they all obviously have different volumes. This takes up less space than this orange. This coin and this block take up less space than this water. So it has to do with how much mass or how much weight is in a certain volume or space of it. Alrighty, so you can try some of those things at home. It's also interesting to get a can of regular soda versus diet soda and try that. The other thing you can do is you can see what happens to an egg when you put it in water. Then you can add a whole bunch of salt to the water to make salt water and put the egg back in there again and see what happens. The second thing you can do to try is to look at some different liquids you might have in your kitchen. So for example, you might try honey or syrup. There's dish soap, there's oil, and I also have milk. So what you can do is you can get a glass, you can pour some of one liquid in there, and then maybe you want to try adding another liquid. So for example, I could put some oil on top. Now you want to kind of pour it to the side because if not it mixes pretty quickly. But if I pour it in slowly, I'm going to, I can show you that. You can see that oil is less dense than water. Maybe you want to try some honey. You could hypothesize, where do you think honey would fall in this? Do you think honey would be less dense than oil? Its density would be between oil and water, or it'd be more dense than water. You can try dish soap and lots of other things you have in your kitchen. So I'm sorry, boys and girls, that we can't be at camp together, but this is one of the activities that we would possibly do at camp. So you can certainly try some of these things using a lot of materials that you hopefully have at home. Take care.